Hey everybody, welcome back to Quesadilla Math. This is your host, Mr. Padilla. Today we're going to be talking about solving rational equations. So let's get started. Now, before we get to solving, we have to learn a very important property about fractions. So what I'm going to do is I'm going to multiply these two fractions by their denominators to see what happens. So if I multiply 2/3 by the denominator, which is 3, I end up getting 6/3, or just 2. But 2 was our original numerator. So in essence, what these 3's are doing here, since I'm taking 2 divided by 3, then multiplying by 3, these are opposite functions, which means they cancel each other out, leaving us with just 2. I can do the same thing with 5 over x by multiplying by x. However, you have to be careful here. You have to make a note that x cannot equal to 0. This is our excluded value, and we have to make sure we state that. So if I do that, of course the x's are going to cancel out, leaving me with just 5. So we're going to use this property a whole bunch today, so make sure you know it well. So our first problem is a very simple rational equation. Negative 4 over u is equal to 6. So we have to solve for u. Of course, if we want to know what u is going to equal, we have to know what it can't equal. And since I am dividing by u here, I need to say that u cannot equal to 0. This is our excluded value, and it's important to know because while we're solving for u, if we happen to get u equals 0, it wouldn't count as a solution. This is what we would call an extraneous solution. So now that we know what u can't equal to, let's apply what we know and try to solve this. So what I'm going to do here, since I'm dividing by u, and this is my only fraction, what I'm going to do is I'm going to multiply both sides of the equation, which I usually show by just multiplying like this. And I'm going to multiply everything by u. So when I multiply u times negative 4 over u, the u's are going to cancel out, leaving me with negative 4. Of course, I have to do the other side multiplied by u, so negative 4 is going to equal to 6 times u, or 6u. So finally, this is a very simple equation to solve. I'm just going to divide by 6. And so negative 4 over 6 is equal to u. I'm going to rearrange this. U is equal to negative, and I'm going to simplify 4 over 6 to 2/3. And since u cannot equal to 0, this is not an extraneous solution, so we have our answer. Now in our next problem, we have 8 over a binomial, u plus 7 is equal to negative 5. So we're going to use the same trick here to solve this problem, except in this case, we are going to multiply by the entire denominator, not just one term. So, of course, we need to find our excluded value first. What can u not equal to? In this case, u cannot equal to negative 7, since u plus 7 cannot equal to 0. So now let's solve. So what I'm going to do is I'm going to take the entire equation and multiply it by u plus 7. So I'm going to go ahead and multiply that out. U plus 7 times 8 over u plus 7. Well, the u plus 7's are going to cancel out, so leaving me with just 8 equals to negative 5 times u plus 7. Now, I didn't multiply it out yet. I'm going to do that in this step. So I'm going to go ahead and distribute out the negative 5. So 8 is equal to negative 5u minus 35. I'm going to add 35 to both sides, getting me 43 is equal to negative 5u. And finally, I will end up with u is equal to negative 43 fifths. So in this next problem, we see that we actually have two fractions this time, which makes it a little bit more complicated, because I can't simply multiply the entire equation by x. Even though it would cancel out this first x, it wouldn't cancel out this 3. And I can't just multiply by 3, because it would only cancel out this 3 and not the x. So what we can do is kind of combine the two. And what we'll do is we will multiply by the least common denominator. In this case, our least common denominator is going to be 3x. So I'm going to multiply everything here by 3x. 3x times 4 is going to give me 12x. When I multiply 3x times 7/3, the 3's are going to cancel out. Of course, I still have to multiply the numerator, so this is going to be 7 times x, since the 3's canceled, meaning 7x. When I multiply 3x times -6 over x, the x's are going to cancel, leaving me to multiply -6 times 3, which is -18. And now we can solve for x. So our solution turns out to be -18/5. But an important thing to make sure is that this is not an extraneous solution. We have to check that it's not one of our excluded values. Of course, in this case, the only excluded value we have is that x cannot equal to 0. This is why it's important to always find this first. So now we know our solution is a true one. So x is equal to -18/5. So our next equation contains 3 fractions, all with different denominators. So we're going to use the same trick as we used in the last example. We are going to find the LCD of these 3 fractions. Now, 20 is actually already the LCD of 5 and 4. So really our LCD should be just 20u. This will allow us to cancel out all of the denominators once we multiply by it. So let's go ahead and look at what that's going to look like. So in multiplying by 20u, all of the denominators were canceled out. So we're left with, instead of 12 over 5u, that becomes 48. 1 over 20 becomes u. And 3 over 4u becomes 15. So now we just have to solve for u, which is a very, very simple one. In this case, 33 is equal to u. Of course, we want to make sure that our excluded values weren't used. But in this case, since we had 5u and 4u in our denominators, the only thing u can't be equal to is 0. So this is indeed our solution. So here in example number 5, we have 2 fractions, each containing a binomial. So we're going to use the same trick of multiplying by the LCD, but we have to figure out what the LCD is going to be here. Now, you might notice that in our second fraction, our denominator 5y plus 30 can actually be factored. We could factor out a 5, and we'd be left with y plus 6, which is our other denominator. So our LCD is pretty simple. It's just going to be 5 times y plus 6. So that's what I'm going to multiply the entire equation by, 5 times y plus 6. And let's see what happens when we multiply that. So after multiplying through, we end up with 20 is equal to -8 plus 5y plus 30, which is a pretty simple equation to solve. We end up getting y is equal to -2/5. Of course, we have to make sure this is not our excluded value. But of course, according to our denominators, the only thing y cannot be equal to is -6. So we're in the clear. -2/5 is equal to y. Our next problem includes a quadratic in one of our denominators. So the best approach in order to help us find our LCD is going to be to factor our denominator. Luckily for us, our denominator actually factors out to y minus 2 times y minus 3, which happens to be both of the other 2 denominators. So our LCD is going to be y minus 2 times y minus 3. Let's go ahead and multiply that out. So now that we've multiplied everything out and gotten rid of our denominators, we can go ahead and solve for y. Of course, we want to make sure we don't get any excluded values, especially here where we might get more than one solution. So let's go ahead and say that y cannot equal to either +2 or +3. Let's go ahead and solve. So solving this linear equation for y simply gives us with y equal to 4. Since 4 isn't one of our excluded values, this is our solution. Now in example 7, we actually have a really special situation where we have one fraction equal to another fraction. In this situation, our best method of solving is going to be cross multiplication. So you can only do this when you have, like I said, one fraction equal to another fraction. It doesn't work when there are more than 2 fractions. But since we have this situation, let's go ahead and try it out. So I'm going to consider this negative to be a part of the 2. So I'm going to move it up here for now. You can do this with fractions. The negative can either be on the outside of the fraction in the numerator or in the denominator. It doesn't really matter. It keeps the same value. So I'm going to go ahead and cross multiply now. So I will have negative 2 times 7x plus 24 equal to x times x. So this is actually going to end up being a quadratic equation because this will end up being negative 14x minus 48 is equal to x squared. I'm going to go ahead and add the 14x and 48 over to the other side and reverse the equation a little bit. So we get x squared plus 14x plus 14 equals to 0. And this is actually factorable. I can actually factor this to x plus 6 times x plus 8 equals to 0. And using the zero product property, I know that x is either equal to negative 6 or negative 8. Of course, we have to make sure that this isn't one of our excluded values. So I'm going to go back here and make sure. My first fraction is being divided by x, so I know that x cannot equal to 0. And I know that 7x plus 24 cannot equal to 0. So x cannot equal to negative 24 over 7. Since none of our solutions are those excluded values, these are our 2 solutions to this particular rational equation. So for example 8, we're looking at an equation x is equal to c over d. No numbers at all variables, kind of like in physics. In this situation, what we're trying to do is we're trying to solve for d. So we're going to use the same tactics we've been using. I'm going to take this equation, multiply it by the least common denominator. In this case is just d. So I will end up with x times d is equal to c. So all I have to do is just solve for d, which means dividing by x, and I get d is equal to c over x. In this situation, we don't have to worry about excluded values since this is really more of a formula that we're working on. So d is simply equal to x over c. Our next example is very similar to the previous one, where we have to solve for one of the variables. Now here again, I'm going to use the same trick as I've been using, multiplying by the least common denominator, which in this case is just y plus z. So I'm going to have to be careful when I do this because I'm going to need to distribute. So I'm going to have w times y plus z is equal to x plus 6 since the y plus z's cancel on the right side. I will get wy plus wz is equal to x plus 6 by the distributive property. Then I will go ahead and subtract the wy, so I get wz is equal to x plus 6 minus that wy. And of course, since I'm solving for z, I just have to divide by w. So I end up with a formula. Z is equal to x plus 6 minus wy all over w. So our last problem today is a word problem, everybody's favorite. And it says, working together, it takes 2 different sized hoses 30 minutes to fill a small swimming pool. If it takes 40 minutes for the larger hose to fill the swimming pool by itself, how long will it take the smaller hose to fill the pool on its own? So we have to write down a couple of pieces of important information. So what we know is that the large hose and the small hose together will fill the entire pool in 30 minutes. So since it takes 30 minutes to fill the pool, in only 1 minute, well, 1/30th of that pool will be filled. So we can say that the large hose plus the small hose equals to 1 over 30. Now we also know that the large hose can actually fill the pool in 40 minutes. So we'll say after a minute, the large hose has filled it 1/40th of the way. We don't know how fast the small hose will fill it up. So we're going to go and call that 1 over x. So now we have an equation, 1 over 40 plus 1 over x equals 1 over 30. And we can multiply by the LCD, which is in this case 120x. So I'm going to multiply all these by 120x, leaving us with 3x, because 120 divided by 40 is 3, plus 120 is equal to 4x, since 120 divided by 30 is 4. Solving very quickly for x, we realize that 120 equals to x. So what this means is that we'll take 120 minutes for the smaller hose to fill this pool. All right, everybody. Thanks once again for joining me. I wish you guys a good day, and bye!